Alright,
Official sign that it's in the homework.
yes, you can turn in the homework.
I wonder if we have to edit
I'm
out.
already getting it started, so you can turn it in a little bit. So we're gonna talk about mean value theorem and Rolle's theorem. Alright, but before we get into that, we're gonna review a couple of topics. We're gonna review something called the average rate of change and instantaneous rate of change. Do you remember talking about that?
Yeah.
What that? A-Rock and I-Rock. Alright, so we're gonna talk about that. Remember the car that I never had? Alright, so before we get started, what I want you to do is, I want you to graph this function f of x, plot the points that are given, and connect the dots, okay? So if you have trouble with that, just kind of follow along with me up here. So 0, 1, right? And then 2, 5, 4, 8, 6, 10, 8, 11, 10, 10, 12 and 8, 14 and 5, and 16 and 1. So it forms a parabolic function, yeah? Parabolic, that's right. This function is what? Increasing then decreasing, so what would we call this point up here? The relative max, right? Okay. What would the value of the tangent line be there? 0, right? So I would have what kind of a tangent line? Horizontal tangent line. Excellent. Okay. So we know that the derivative is just the what? Slope of a tangent line, right? And we know that slope, another word for slope is rate of change. So it's telling me how something is changing, okay? The rate at which something is changing. We did a lot of that when you did related rates, right? You have to pay attention. The rate of the volume is this, right? Or the rate at which this is increasing or decreasing. So there's two different rates, the average rate of change and the instantaneous rate of change. Do we know the difference? What would you consider average rate of change to be? Anybody remember that one? Very good. So average rate of change is, what's the rate of change from this point to this particular point? So I'm given 2 points and I'm finding the slope between them. So that's the slope that you've worked with since you were maybe in 8th grade, 9th grade, Algebra 1, Geometry, Algebra 2, Pre-Cal, right? The basic slope formula. y2 minus y1 over x2 minus x1. Okay, so I use a little acronym and I just say A-Rock for average rate of change. And the way we find it is on an interval from A to B, the average rate of change, aka A-Rock, is found by what? How do I find the average rate of change between A and B? What do we say right now? Find the slope between the 2 points, okay? So we could use the slope formula. So what would that be? y2 minus y1? Okay, that's one way of saying it. What would be a fancier way of saying that using function notation? No, function notation. Okay, well if we're doing y2 minus y1, it wouldn't be f of a, it would be what? F of b minus f of a over b minus a, right? That's how I would find the y values if I knew the x values were a and b. Would it still be okay to do it the other way like Luis said? F of a minus f of b? But then on the bottom I would have to have what? A minus b, right? Wouldn't that? And that would be equal to the slope that we're used to working with, which is the slope between 2 points. Super easy? Alright, so at the bottom, when they ask a question like this, are you gonna freak out? Find the average rate of change of f of x on the interval 2 to 12. What kind of values are these? Is this a point or is this an interval? Interval, so they're what kind of values? Those are x values, so what do I need for those x values to find the average rate of change? The corresponding y values. So what would be the corresponding y values? 5 and 8. So my points would be 2, 5 and 12, 8. So if I wanted to find the slope, what would I do? 8 minus 5 over 12 minus 2, right? What would be a fancy way of writing that? Instead of doing y2 minus y1. It would be like saying f of what? 12 minus f of 2 over 12 minus 2, right? What do we end up with? 3 over 10. Super easy?
Yeah.
Alright. So on the graph at the top, I want you to draw a line that goes through those 2 points, 2, 5, and 12, 8. Go to the graph and draw a line using your rulers. If there isn't a ruler on your side pocket, let me know. I have an extra one up here. You don't have a ruler? Draw a line from 2, 5 to 12, 8. What do we call that line that intersects the curve at 2 points? Secant line, right? Okay. So when we're finding average rate of change, we're actually also finding the slope of a secant line through those 2 points. Cool? Would be like finding the average rate of change. We've got 3 over 10. So for slope of a secant line, I use SOS. Okay. What do we use for slope of a tangent line? SOT. Which one's the other one we use? SON. What's that one for? Slope of the normal line, right? Cool? Alright. So far so good? Alright, so down here under A rock, let's just add that. Slope of a secant line. We're going to use these formulas later on in Rolle's theorem and mean value theorem. That's why we're reviewing them, okay? So, the other one is instantaneous rate of change. What is that? I rock. I know I rock. Thank you. Everybody tell themselves that. I rock. Awesome. I'm glad you feel that way. So, I rock stands for instantaneous rate of change. Okay? And it's the instantaneous rate of change at a particular point. So what do I use to find the rate of change at one particular moment in time? The derivative, right? Okay. So let's write that down. So at a value x equals a, the instantaneous rate of change, aka IROC, is found by, how do I find it? You said what? By using what? By evaluating the derivative at that value, right? So f prime of a, we call that the derivative at a, for x equals a. And another acronym that we could use is the slope of the tangent. So up here under IROC we could say what? Slope of the tan line is what IROC would be equal to. Good. Look at the next question. It says, is the instantaneous rate of change of f at 4 greater than the instantaneous rate of change at 6? Okay? So how could we figure that out?
Find the derivative and plug in both.
Find the derivative and plug in both, okay? So do we have a function to find the derivative of and plug in both? No. I don't wanna sit there and come up with a function for it. See which one's what, Robert? Steeper, okay, so the steeper the line, the greater the slope. Okay, cool. So let's check it out. So I'm gonna go to 4, and I'm gonna draw a tangent line at that point as best as I can. And then I'm gonna compare it to the other tangent line at what? 6, right? And which one would be steeper? Which one is harder to climb? The one at 4 or the one at 6? So which one would have a greater value? The one at 4, so how would I say that? F prime at what? 4 is what? Greater than F prime at 6, because? The tan line at x equals 4 is what? Steeper than the tan line at x equals what? 6. If I drew an infinite number of tan lines on this graph, what would you notice is happening to the tan lines as it gets closer and closer to 8? They're getting less and less steep, right? So that means that from 0 to 8, the function was increasing, but it was increasing at a what kind of rate? At a decreasing rate, right? Because the slopes are getting less and less what? Steep, getting closer to 0, right? And then what happens after that?
They're increasing.
It's now the function is decreasing, but at an increasing rate, right? The slopes are getting bigger and bigger and bigger. So it's kind of like when you shoot a gun, right, and the bullet goes off. That bullet is going up and up and up and up, but as it's going up, it's starting to go up at a slower what? Rate every single time up until it reaches its maximum, right? And then that bullet starts to what? Come back down, and what happens to the rate at which it falls? Starts getting faster, right? So it accelerates a little bit. Cool? Got it? Kindergarten stuff? Average rate of change, slope of a secant line, slope between 2 points. Instantaneous rate of change,
Slope of the tangent line.
slope of the tangent line, derivative at that value. Papitas? Yes? Alright. Let's look at Rolle's theorem. Rolle's theorem is actually a special case of the mean value theorem. I could technically just teach you the mean value theorem, and that's the only one you really need to know, because Rolle's theorem is just a special case of it. What I'm going to go over here is the conditions that have to be satisfied in order for Rolle's theorem to apply, and what Rolle's theorem guarantees if those conditions are satisfied, okay? And then what we'll do is we'll do some exploration, we'll do some examples, and then that'll be it for today. We'll stop at Rolle's theorem, and we won't get into mean until Monday. It'll be nice since it's Friday. Sounds good?
Yeah.
Unless like you're into it and you want me to do the mean value one with me, we'll just knock it out of the park.
Knock it out of the park right now.
We'll get it out of the way? Alright, well let's look at it. So, for Rolle's theorem to apply, these conditions have to be satisfied. So, if 1, f of x is continuous on the closed interval AB, that's the first thing. F of x has to be continuous on the closed interval AB. The second thing that has to be true is that f of x has to be differentiable on the open interval AB. Okay? So what's the difference now between those?
One includes and
One includes the endpoints and one doesn't include the endpoints. So are we going to run into problems when we do the square root function? What kind of point of view are we going to take? The purist or the non-purist? So if I do a square root function, would we say it's continuous at that endpoint?
Yes, from the differentiable.
So you're gonna say yes? If you say yes, it's from a non-math purist point of view. Right? Because we cannot approach from the left, so therefore the limit would not exist from the left. So you're gonna run into that situation. You won't run into that on the AP test because there's a gray area, right? Some people believe it is, some people do not believe it is, so they won't do that on the AP test. But I did throw one of those on the actual test. I mean on the assignments.
Oh, that was like, what test?
We'll see what you come up with, okay? Technically, this would not be continuous at the end point because it doesn't satisfy the conditions for continuity. Okay?
Do you consider yourself a math theorist?
I don't know.
You're weird. I know we all see it.
Something like I look at it and I think it's continuous, but
Yeah.
you know, like I don't see it as being a point of discontinuity. But like in a way I do and in a way I don't. The third condition is that f of A must equal f of B. So that, what does that mean?
Yes.
Where it starts should be the same place as where it what? The same y value, right? Not the same exact point, but the same y value. Good? If those three things are satisfied, then you can say that